All right, we have one more set of talks, and I'm going to start with how to write documentation and tests for YT. This is a very important part of the development cycle with YT because without documentation, how is anyone going to know how to use your tools? Very briefly, we're going to go over the aim of documentation and how to document strategically and how to do it when and where and why. We use Sphinx as the tool to build our documents. If you go to the YT page and look at the documents, that's actually the output from Sphinx. I will show you how to add new documentation and ideas for how you can contribute to the documentation. You can contribute to the documentation even if you haven't written anything for YT. If you find there's a bug in the documentation where it's incorrect, or you feel like you can add something to a tutorial because you figured out how to do something, that's an idea. And how to write tests comes at the very end. The aim of documentation is really for you to describe what you just did or describe the thing. And you really want to have it in mind for the intended audience, which is someone who has an idea of what they want to do or use this tool, but they've maybe never used YT before. Often that includes how to run it by including examples, which show some common usages for this tool. And then finally, if it's parallelized, you're going to want to also include how it's parallelized and how to run it optimally when you're running in parallel, because sometimes there's differences. Like Sam said, we have volume-based and grid-based and object-based parallelism, and you should describe which kind your new tool is working with. I find the best strategies for documenting is to do it right when you add the tool, no later, or else you forgot what you did. I have added a number of things to YT, and I still go to the documents to look at how to use my own tools because I forgot. And you will too. So if you document what you just wrote as soon as you write it, that'll save you time because you won't have to come back and figure it out again when we're going to put a release out and Matt's bugging you, hey, can you write documents for that tool? Because if you don't, that's that part, you know, we can't release it until you get the documents out. And also, the second bullet point you see here is that a lot of the documentation actually goes with the code you write using doc strings, which I'll explain in a few more slides. So like I said, it goes in line with the code, and it also goes into a whole separate Mercurial repository from YT called YT doc. If we look on the web page, which direction am I? Over here. All right. If we go to the web page and a Bitbucket, and we scroll down to YT analysis, you'll see that it has its own repository, YT doc. And just like Sam showed you, if you wanted to add the documents, you'd fork this, commit your changes, and do a pull request. The documents are written in plain text using the restructured text markup language. This is it's kind of like LaTeX. I'll say in a few more slides to show you some examples of this. But basically it's a what you mean, not what you see language. And it uses Sphinx to actually build the documents, which is a Python package, and it outputs things in HTML and LaTeX and other things. So first, let's describe what a docstring is. If you've ever looked at the YT source, you'll see that a function is defined like this: def write out with the arguments of the function. And then below it, you'll see this R with triple quotes, and then text below it. There is a standard form for this, which is under docstring example.txt, which shows all the things you should include in a docstring. Now, why would we want to do docstrings? Well, for one thing, the docstrings show up in the documentation. So this last function that I just showed you, which happened to be for the star particle analysis module, if we go to the website, this is now on the web. this docstring that was in the function. It's automatically done. Furthermore, from the command line within YT, when you say help on that function, you get what was put into the function docstring with a triple quotes. So if you want help on your newly written function to be useful, you have to add a docstring, or else it's just not as useful for people. Another way that you document what you've done is to have useful and illustrative comments scattered throughout your code. So here, at line 1, I say, well, we're going to sum up the stars created in each time bin. And then the next 2 lines do that. And then at line 5, we say we calculate the cumulative mass by forward adding. And then we do that. And so it helps people read along in the code and say, well, I know something's wrong. I'm getting wrong sums. Maybe there's something wrong in this code. And they can just zoom in on the code and find out where that's happening. So again, we use Sphinx, and it takes plain text files and outputs them in HTML. Sphinx is just a Python package, and you can install it with pip install Sphinx. I don't think it has very many dependencies, so it won't take very long. I don't suggest that you do it right now. You can try it when you actually write some documents. REST is very simple. It's plain text, and it's similar to LaTeX, that it's what you mean and not WYSIWYG. You describe things like sections and headers and blocks, but you don't, it's not like Microsoft Word, where you see what you're writing as you write it. But it's handy. It has cross-references like LaTeX, so that you don't have to constantly update references. It just does it for you automatically. You can include images and movies and code snippets and LaTeX equations and things like that. So when you come to write new documents, there's a few things you need to do. You need to have a sufficiently detailed description of the thing. Maybe start with a motivation. I'm writing this widget because you are building a widget factory, and this is how widgets work. And you need to know what widgets are. So this is what this document describes. A technical summary. This could be describing what goes into a widget. It's got 4 gears, three strings, and a battery. And please see, Dr. Seuss et al. 1967 for more information. That's something you'd want to include if there are references. Descriptions how to run it. Like I said, you want to include examples. A widget goes down your pants and tickles your toes. I mean, what else does a widget do? And if there's images of the output or movies, you also want to include that in the documents. As I said before, the work cycle to adding documentation is very similar to the work cycle to changing YT. You clone, make your changes, with a fork, I mean, then you issue a pull request, and every time you make a change, you go through the same number 2 and number 3 there of making your changes, committing, and issuing a pull request. If you are adding a document, it's often a bit daunting to say, well, what's all the different formatting I do in a Sphinx, a REST file, a restructured text file. I find the simplest thing is first you need to find out where you want to put it, and then look and find an existing text file, and then basically base your new file on that existing file, copying the way headers are done, the way images are included, or text code blocks, and I'll show all of these things in a couple slides. But then once you write your document, you have to make sure it's referenced, because if it's not referenced, it'll just be sort of orphaned in the documents. And that's done by adding a reference to the file in the appropriate index.rst. If you look at how the document that you referenced, so the actual text document you referenced to build your reference, and you find how it's referenced in an index file, you can basically match your new file to that existing reference. And then you commit and push and pull request and all that. So what does REST look like? Well, it's very simple. Like I said, it's like LaTeX, and then you describe what you mean. So you start with a section, and every header is underlined and sometimes overlined by characters that are at least as wide as the section header. So here, section has equal signs as wide as the word section, and we get this large, bold section title. Subsection has tildes, and it's a smaller but still bold header. And then words is the body of your text, which is normal size and not bolded font. You can give your regular text, your body of your text formatting. You can have italics and bolds. If you were referring to a variable or something that's a code name or something like that, it's often best to surround it with these double quotes so that it comes out in a fixed width font and it looks like you're referencing a variable or a function name and not a something that's more conversational. You can make hyperlinks in REST. Here's an example. So if you were to type out external hyperlinks like backquote Python homepage and then those characters, what you would see in your output in your HTML would look like that, where Python homepage is turned into a link that you can click on. Are there any questions so far? It's all very simple, so hopefully not. You can have internal hyperlinks. These are links from one document to another or from inside one document to another place inside the document. And it's a two-part process. First, you have to have the target, which is named with this 2 dots and then this underscore example colon. And then to reference it, you reference the name with a trailing underscore. And then when you actually see the text as its output on the HTML, it looks like at the very bottom, where example underscore has been replaced with a link that goes to wherever the dot underscore example is. And it can be in the same file or a different text file, completely. Where the target is and the reference. One nice thing about REST is you can include code examples that are set out visually in the documents from the rest of the text so that people can look at it and say, oh, here's Python code that it's the best place to put examples. So it starts with this code dash block, as you can see here, and then you include your code below it. You have to be careful about the number of leading new lines and spaces. So there's both new lines between the code block and after the code block. So between the code block statement and the actual code, and below the code, there has to be a blank new line. And furthermore, the code itself is indented by, I think, at least 2 spaces from the beginning of the text document, that is. Lists are really easy in REST. You can see here, again, you have to be careful that there's new lines between the top and the bottom, above and below your list, and your list has to be indented. But it's just this simple. You type on the left and you get what's on the right. You can do auto numbering in lists. So you don't have to, if you add a new item in your list between what's already existing, you have to go through and change all the numbers. It'll do it for you. Including images is very simple. Just like the code block that starts with a ... You reference the image. You can have just like in HTML, if you've done HTML, you can either have absolute references to images or you can have relative references to images. And if you're confused, just take a look at what's already been done in an existing text file, and you get your image included in the output. Are there any questions so far? So how can you contribute? Well, you can improve the tutorials. If you've just learned YT, maybe you know, wow, this thing has really confused me, and I had to ask someone what's up with this. I can go to the documentation and write this down because I was confused about it, so someone else probably will. Us developers, you know, when we were confused about this was a long time ago, so we don't think this is confusing anymore. But if you're new and you found it confusing, don't be shy. Think about adding the documentation so someone else doesn't get confused. We're not the right people for doing that. If you see an error or typo, you can fix it. If you think that there's missing references or one section of the docs could use to be linked to another section because they're related but there's no link and you're confused at why they were separate, you can fix that yourself. Another important part of the development cycle is writing tests for your new code. There's reasons why we do this. We want to make sure that what we just wrote works the way we expect, and you do that with a test. Also, all of us developing or changing YT over time, and we want to make sure that answers don't change, unless of course they're supposed to change. But writing a test allows you to see when it does change. And there's a way to write tests in YT, and I'm going to show you a little bit of that in the next couple slides, where you can check for identicality of values or arrays, or you can make sure that they're only different by a small amount. So if they're something that can change a little bit, you can say, well, it can only change by 1 part in 10 to a million or something like that. Also, you can output plots, which can be useful to just make sure there's nothing ridiculously wrong about your code or anything like that. So after you've added a new capability to YT, tests need to be done. There's 2 places you have to look to do tests. Inside YT utilities answer testing, there's already a few tests in there. And then once you've written the test itself, you have to go to the folder tests, which is under the top level, and you'll see how these tests get called. So for example, in the YT utilities answer testing, almost all of the files start with lines like this, which calls the necessary modules, including these single output tests, YT static output test. Those are the things that allow you to do comparisons between runs. For example, here's a test of the halo finder. And what this test does is it's going to run the halo finder and count how many halos there are. And the number of halos that the halo finder finds shouldn't change as YT gets developed. Because if you're changing something in the volume renderer, why should the number of halos change? So it's a really simple test, but you know, someone could accidentally edit a file or delete a file or something that would change the number of halos. And it's really simple. It's got these 3 sections. We have the run section, the compare section, and the plot section. The run section basically does 2 things. It does the actual running of the analysis module you're testing, and in this case, it runs the halo finder. And it also stores what you're going to compare in the self result. And here I'm just storing the number of halos, the length of halos, which is of course just a list. And then compare, the second function, it's to saying, what's the criterion I'm looking for? Well, I want to make sure that the new result and the old result have no changes. That's what the 0 is here. And then finally, the plot. I'm not plotting the number of halos. That would not be a very interesting plot. So that's just, it returns nothing. And so how do we call this? If you look into the tests folder, we've imported the testing things, and we're also importing these functions. So if you notice, this previous function was named test halo count hop. And here, just after on line 4 at the beginning, I'm importing test halo count hop. And then I'm creating the test halo count hop, and I'm giving it a string, which is how its results get stored. And there's a parameter, which you might have noticed that in the run, there's a threshold, a self.threshold. I can change the threshold right there. These tests are run quite often. They're run for the medium ones, they're run every night. And then the small tests are run every half hour. So, and again, just like the documentation for the tests, really the simplest way is just to look at the existing tests, see what's done there, and copy them for your own purposes. Yes? I believe, yeah, it's done on Matt's computer. The question is, where does the testing done? It's done on Matt's workstation. And so with that, I'm finished. Are there any more questions? Okay, thank you.